We are recording Friday, February 6th, WSSB. This is a gift for our Algebra 2 students. I'm going to go over a few problems that might be closely similar to, related to the quiz, take-home quiz questions you're working on this weekend. And so you may listen to this, follow along, work the examples I'm going to do, and it should then help you to do extremely well on the questions that you have for your quiz. So the first example I'm going to do is the square root of simple fraction open 9/7 simple fraction close. And that's the square root of 9/7. So the first thing you should do is you should use your quotient property and separate the radical to the numerator and the denominator. So the square root of 9/7 is equal to simple fraction open square root of 9 over square root of 7 simple fraction close. Now you focus on the numerator and the denominator and see if you can simplify them. Well, the square root of 9 is a perfect square, and that is simplified to 3. The square root of 7, the only factors are 1 and 7. Square root of 1, square root of 7, neither of those are perfect squares. So we have 3 over the square root of 7. Now, if you leave it like that, that's not totally simplified because we have a radical in the denominator. So you need to do the process of rationalizing the denominator. In other words, we're going to get the radical out of the denominator. We're going to multiply something times the numerator and denominator to do that, to simplify, get that radical out. Well, in this case, because we're in square root land, we're going to multiply by the square root of 7 to the denominator, right? Because square root of 7 times the square root of 7 would be the square root of 49. And that would be 7, wouldn't it? So if we multiply the denominator by the square root of 7, we have to follow by multiplying the numerator by the same thing, the square root of 7. It's fractional. So we have 3 times the square root of 7 in our numerator position. So we just write that, 3 square root of 7. And that's all over the square root of 7 times the square root of 7, which I just said earlier is the square root of 49, and the square root of 49 is 7. So your final answer to the square root of 9/7 is 3 square root of 7 all over 7. All right? So that is simplifying a square root of a fraction and rationalizing the denominator. All right, now I'm going to do the cube root. So we're going to have cube root, the third root of, let's do 6/8. Okay? The cube root of 6/8. You know what? I'm going to change that. Let's do the cube root of, I don't want it to be something that we can simplify underneath. I'm sorry about that. How about the cube root of 5/8? Okay, the cube root of 5/8. So cube root, simple fraction open, 5/8. So once again, you need to break this apart using your quotient rule. And this is the same as the cube root of 3, or excuse me, cube root of 5. I wrote a 3 with my cube root, all over the cube root of 8. So we do a simple fraction open, cube root of 3, cube root of 5, all over the cube root of 8, simple fraction close. So we can simplify the cube root of 8 to a 2, can't we? So this would be the cube root of 5 all over 2, and we're done. There's no rationalization of a denominator in this place, right? Because we were able to say 2 times 2 times 2 is 8, right? So the cube root of 8 is 3. So this one's done. And sometimes that happens. Now, let's do the fourth root of something. So we're going to have the fourth root of, let's do 3 over 4. The fourth root of 3 over 4. So again, break this apart using your quotient rule, and this would be the fourth root of 3 all over the fourth root of 4. So none of those can simplify. There's no factors of them that we can do to factor them out and simplify. So what we're going to do is build up the fourth root of 4 to something that we can simplify. So think about your fourth roots and start with the number 2. So 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. Is there something we can multiply 4 by to get 16? And it's 4. So the fourth root of 4 we could multiply by the fourth root of 4, and we would get the fourth root of 16, which is 2. So we're going to take the fourth root of 3 over the fourth root of 4, and we're going to multiply it by the fourth root of 4 all over the fourth root of 4. We're rationalizing the denominator. We're getting the radical out of the denominator. So in the denominator position, the fourth root of 4 times the fourth root of 4 is the fourth root of 16, which is 2, right? And then in the numerator position, we do the fourth root of 3 times the fourth root of 4, which would be the fourth root of 12. And double check your factors of 12 and make sure there's no fourth roots in there. There isn't, right? We need it to be 16 to get the first one, right? So that's the final answer, the fourth root of 12 over 2. So notice we had to build up that denominator to something that we could then simplify to a whole. All right, now let's throw variables in the mix. Let's do the cube root. So the cube root of x to the second power over, let's do 3y. X to the second power over 3y. Just making these up. I hope I made up a good one. So again, use your quotient rule and break these apart. This is the cube root of x squared all over the cube root of 3y. All right? Cube root of x squared all over the cube root of 3y. So we can't factor out the x squared into any cube root, so we leave that alone. The cube root of 3 is not perfect, so we can't factor anything out in our denominator. So we need to figure out how to rationalize our denominator. So what are we going to multiply the cube root of 3 by to get it, cube root of 3y, excuse me, to get that denominator out? Well, we need the y to become y to the third, so we know that we're going to need a y to the second, right? Because y times y to the second is going to get us y to the third. Now, what times 3 is going to get us our first cube root? Well, we know 2 times 2 times 2 is 8. That's not going to get us it, right? But 3 times 3 times 3 is 27, right? So we need to multiply this by a 9, right? So the cube root of 9y squared, if we multiplied that by the cube root of 3y, we would have 3 times 9 is the cube root of 27. Y times y squared is the cube root of y to the third. Well, the cube root of 27 is 3, and the cube root of y to the third is y. So we end up having 3y that we factor out. Does that make sense? 3 times 3 is 9 times 3 is 27. If we multiply the denominator by the cube root of 9y squared, we have to multiply the numerator by the same amount to keep it balanced, to keep it equal. So we're multiplying the cube root of x squared times the cube root of 9y squared. So we end up with the cube root of 9x squared y squared. All right? And we can't simplify that any further, so that's our final answer. The cube root of 9x squared y squared all over 3y. So those were several examples of how to simplify radical expressions with fractions and rationalizing the denominator. You need to really, really get a hang of this. This is like knowing your facts, and it's your algebra facts. You've got to be factoring machines, and you need to be able to simplify exponents and radicals again and again and rationalize the denominator. So I'd highly recommend that you take a look at your quiz, probably watch this video again, maybe stop it after a problem and recognize that it's similar to a quiz problem and apply it to your quiz and get the correct answer. All right? Your quiz is due on Monday. Have a good weekend.